Hello, my bomb blowers and module masters, and today I am here with another Keep Talking and Nobody Explodes modded module tutorial, and today I am here with the module Complexity. Complexity is a very alien-looking module, but really it is just encrypted numbers, and you're doing calculations with the imaginary numbers. Let's go in and get started. This module requires no edge work, so we can get started as soon as we get our bomb. So here's complexity.
There is only one perfect solution.
So there's a lot of stuff on this module, and it all looks kind of nonsensical, but let me explain what everything is here. So as you may notice, there are only 4 things you can actually select on the module. So you have these 2 buttons here, which change this line. You can press it as many times as the module will let you, and the number of times you can press each button before it reverts back to this flat line is different for each button. So you saw that I pressed it 4 times and went back to the straight line, but for this one I had to press it 7 times. There's also this button. This will append whatever this is to your answer. So if I press this button right now, the first part of my answer will show up here, and this will be the first part of my answer. There's this button, which acts as a submit button. There's this display, which acts as 2 numbers. We'll get to the numbers later. And then there's this display, which acts as an operator. So this module has 3 stages, and in each stage, we're going to convert the display from this encrypted nonsense into actual numbers. We're going to do an operation with the encrypted numbers, and then we're going to input our answer using these. You'll also notice there's a bit missing from the bottom right of the module, but all of this is that this is supposed to be a negate button, as in this is a button you press to negate your answer, but haha, the module's funny, so this is actually missing, meaning we just submit the absolute value of the answer. It's hilarious. Just don't worry about it. Anyway, how do we interpret what we're seeing here? So as I said before, the module uses imaginary numbers. And if you don't know what an imaginary number is, it is just represented by the letter I. So whenever we have a line segment with 2 different ends, the left side of the line is corresponding to a number in a certain base, and the right is corresponding to a different number in a different base, multiplied by I. So the left could be interpreted as, say, 6, 4, and the right could be interpreted as 3, 4. And because it's on the right side, it automatically has an I appended to it, as you see in the value column. So, for this top number here, this is the first digit of the real number, and this is the second digit of the real number. These are both zeros, so it's going to be 0, 0. We're also going to put a plus sign in between both ends of our number. The right side is 1 and 1, I. So, whatever this number is 0, 0 plus 1, 1, I. And then we're going to take this operator, which is multiplication. Then, the first digit of the second number on the left is 0. The second digit is a 4. That's the end of the first number, so we're going to put a plus sign in between the number with and without the I. And on the right side, we have 3, 1, I. So let's discover what bases these numbers are actually in, because these are not in base 10. So we're going to press this until it goes back into a straight line. Okay, so the last thing that we saw was this symbol, which corresponds to 6. So the next highest value that the display cannot reach. So 7 is the highest value that the display cannot reach, meaning the left number is in base 7, which is the 0, 0, and the 0, 4. So we know that 0, 0 in base 7 is just 0, and 0, 4 in base 7 is just 4. To convert a number from a base 10 number to a different base number... I'm sorry, from a different base number to a base 10 number... We'll get into that later, actually, because we're about to get an example here with the second numbers here. So, next we're going to identify which base the right side is in. The highest number it went up to was 3, so we're going to take the number after 3, which is 4, which tells us that the right side is in base 4. So, to convert a number from base something into base 10, so our right number from base 4 into base 10, because we're going to need to do this in order to perform the calculations. You can perform calculations with the bases, but that's beyond my pay grade. So we're going to multiply the rightmost number by whatever base we're in to the power of 0. So 1 times 4 to the 0 is 1. Then we're going to add the next number times whatever base we're in to the power of 1. So this is 1 times 4 to the 1, which is 4. Now that we don't have any more digits, we're done converting. We're done actually getting the value of the digits. We add these up, which means that the value of 1, 1 in base 4 is actually a 5 in base 10. So I'm going to label this as a display. I'm going to label this with a 1 to show it's in base 10. We're going to do a calculation in base 10. Then we're going to convert it back into base 7 and base 4, because we have to convert our result from doing the math into whatever bases that we have. So this is 0 plus 5i multiplied by 4 plus, we have 1 times 4 to the 0 plus 3 times 4 to the 1, which gives us 13. So this is 4 plus 13i. So we're going to take the result of whatever this is. Now, if you just put this in the text field calculator, it's going to give you the result. But this is lame. So let's tell you how to actually do this the normal way. So as you can see here, this is what happens when you take two numbers in this form, multiplied by each other. 0 is going to correspond to A, 5i is B, 4 is C, and 13i will be D. We're going to take the sum of all of these. So the sum of the left and the left of the right is 0 times 4, plus A times D, which is 0 plus 13 times 13i. Then add 5i times 4. Then add 5i times 13i. So these two just go to nothing. 5i times 4 is going to be 20i, and 5i times 13i is... oh, my bad. I need to put these in parentheses because that changes the outcome. Anyway, and then 5i times 13i is going to be 60 times I squared. And I squared is equal to negative 1. So 60 times negative 1 is negative 60. Now... oh, my bad. 5 times 13 is 65. So this is actually negative 65. And as you can see, this is the simplest form that the text field calculator has given us that our number is actually in. So this is what we're actually going to submit to the module. If we have a negative number, we're just going to take the negative away from the number. So we need to submit 65 plus 20i into the module. So how do we do this? We're going to convert the left number into base 7. So to do this, we're going to take the number and divide it by the base. We're going to take note of the decimal, and then take the number to the left of the decimal, and divide it by 7 again. We get the same decimal. And once the number before the decimal is less than whatever base we're in, we're just going to note that down instead. Then we multiply all the decimals by the base we're in. This is 2, and this is going to be the same thing, which is 2. We're taking the result from bottom to top. So 122 is going to be 65 in base 7. And we can actually confirm this. We can take 2 times 7 to the 0, plus 2 times 7 to the 1, plus 1 times 7 to the 2. And this gives us 65, which means we have put this in base 7 correctly. Now we're going to convert 20 into base 4, and then we're just going to stick an I on the end of it. So 20 divided by 4 gives a decimal of 0. 5 divided by 4 gives a decimal of 0.25. And then 1 is less than 4, so we keep that. This gives us 1. This gives us 0. So 20 in base 4 is 1, 1, 0. And we're going to stick an I to the right of this. The module will automatically stick an I on the right term because the left term corresponds to the number to the left of the plus sign, and the right part of the line will correspond to the number to the right of the plus sign. And the number to the right of the plus sign will always have an I at the end of it. You can treat I kind of like an X that we don't know. Mainly because I is a value that we as humans don't know. It is equal to the square root of -1, as you can see by this. But that's not a number that we can calculate. But anyway, that's not for me to discuss. Let's input this number into the module. So, we're going to input the leftmost digit of both of our numbers first, then the second leftmost digit, and then the third leftmost digit. If we had any more, we would input the fourth leftmost and the fifth leftmost and so on. But since we only have 3 digits for each number, we're going to input the third from left, then the second from the left, then the leftmost, then second leftmost, and third leftmost. Now, if our base 4 number was just 10i, for example, then we would just put 010i, because we're going to have to input 3 digits, or inputting the number of digits that is the large number of digits that need to be inputted. Let's input this. We're going to submit 1, 1. 1 on the left side of the line corresponds to this, and 1 on the right side of a line corresponds to this. We press this to append the symbol to our answer. Now we're going to input 2, 1. This is 2, and this is 1. Now we're inputting 2, 0. This is 2, this is 0. So, 1, 2, 2, and 1, 1, 0. This should be the correct answer, so we're going to press the submit button. And that is correct. And now we get to another stage. The module will solve once we do all 3 stages, and the bases of the left and right side of the numbers are going to stay consistent through each stage. It even stays consistent if you get a strike. Getting a strike I do not believe resets. A strike will reset the stage. So if you get a strike by inputting the wrong thing, you'll just get a different stage, but you're not going to go back to stage 1, and the bases will stay the same for the left and right side of the number. So we've got 2 more stages to do examples of. So our operation for this stage is subtraction. The display value is going to be whatever this symbol is, which is 4, and then this second digit, which is a 1. We put a plus in between both sides of the line. Whatever this is our first digit, so 0, and this is our second digit, which is a 3. And since it's on the right side of the line, we put an I here. Now that's our first term of the equation. Not the first term, but the first thing we're going to put in our equation. This is subtraction, and now we do the other number. This is 6, and this is 4, plus this is 2, and this is 0. It's on the right side of the line, so this is going to have an I after it. So let's convert these numbers into base 10. 1 times 7 to the 0 plus 4 times 7 to the 1. Oh, that's a 6, my bad. 1 times 7 to the 0 plus 4 times 7 to the 1 is 29 plus 3 times 4 to the 0 plus 0 times 4 to the 1 is 3. 6 times 7 to the 1 plus 4 times 7 to the 0 is 46. And then plus 2 times 4 to the 1 plus 0... Oh, 2 times 4 to the 1 plus 0 times 4 to the 0 is 8. And we stick an I on the right of it because it's the right side of our term. So now we're going to take whatever this is. We can put it in the Texio calculator to make sure that we have the right answer, and we should be getting this. Of course, we're going to remove the negative sign because we here in Complexity Land don't know what a negative sign is. But if we're going to do this without using the Texio calculator, then how we would do this is we're going to take the difference of the numbers on the left side of the plus sign on both of our terms. So 29 minus 46 is negative 17. But we're only concerning ourselves with positive numbers, so this is actually 17. And then we're going to take 3 minus 8. This gives me... Oh, my bad. I forgot to put them in parentheses again. Alright, now this is actually what we're getting. 3 minus 8 is negative 5, but we here in Complexity Land only concern ourselves with positive numbers. So this is the number we're going to put into the module, 17 plus 5i. We convert 17 into base 7, 0.4285. Then 2 is less than 7, so it's going to be our last digit. Multiply this by 7, this is 3. Actually, that's our first digit. So bottom to top, 2 then 3 is going to be our number in base 7. 2 times 7 plus 3 is 17, so that confirms we're correct. Then we're going to convert 5 into base 4, 0.25, and then 1 is just less than 4. We multiply this by 4, which gives us 1. From bottom to top, this is, 11i. So now we're ready to submit this. We take our left number, the leftmost digit, then moving it right until we're out of digits, and then the right number, take the first digit and move right until we're out of digits. So we're going to input 2, 1, then 3, 1. This is 2, this is 1, this is 3, this is 1. Okay, this should be our answer, so let's press this button to submit, and then it's good. We have one more stage. So let's get rid of this, and let's do this. So our display is, this is 2, and this is 4, plus, this is 3, and this is 1. And then we stick an I on it. Then we take our operator, which is plus. This is 4, and this is 1. Plus, this is 0, and this is 2. Stick an I on the right of it. Now, notice that we can represent the 0, 2i as just 2i, and this will function as the same number. But in order for it to be printed in the encrypted number system that the module uses, we have to append the single-digit number with a 0, because the other number has 2 digits. And we have to input the same number of digits for both of our numbers. This is a 2-digit number, but even though this is a 1-digit number, we have to make it be 2 digits, so we're going to prepend a 0 to it. Okay, so let's convert our numbers into base 10. 2 times 7 plus 4 is going to be 18, plus 3 times 4 plus 1 is 13i, plus 4 times 7 plus 1 is going to be 29, plus this is just 2i. So we can put this in the Texio calculator to make sure we get the correct answer. Make sure we put these in parentheses. we should get 47 plus 15i. So how we would normally do this is the left side plus the right side gives us 47, and the left side plus the right side gives us 15. Simple as that. So, now we're ready to submit. We convert 47 into base 7, which gives us 0.714, and since 6 is less than 7, we just take 6 as the first digit. Multiply this by 7 gives us 5, which means that 47 to base 7 is going to be 6, 5. We're going from bottom to top. And then we're going to convert 15 into base 4. We get 0.75, and that's less than 4. From bottom to top is 33i. Input the leftmost digit, then go right. Input the leftmost digit, then go right. So we're inputting 6, 3, and then 5, 3. This is 6. This is 3. This is 5. This is 3. This is what I desire to input, so we press this, and the module is solved. Now, once again, I would... Actually, no, I will do this example because this just so happened to roll division, and we have not done a division problem yet. So since this is a new module, we're going to have different bases on our left and right side. So we're going to find the biggest number that the left side of the display can go up to. It looked to be this, and then the base is going to be the number after the biggest number that the left side can go up to. And then the right side went up to this, so the base is going to be the next highest number, which is also base 5. Okay, so let's convert this into base 10. We have, what's this? 2, 4, 2 plus 0, 0, 4i divided by, this is 4 and this is 0, 0i. So, we're taking 2 times 5 to the 0 plus 4 times, 2 times 5 to the 0 plus 4 times 5 to the 1 plus 2 times 5 to the 2. Which means the left number is 72, plus, this is really just a 1-digit number, but we had to prepend zeros to make it 3 digits since the left number was 3 digits, so this is just 4i. We are dividing this by... This is just going to be 4, because there is no I component. Whenever you get a division problem on complexity, the division should be relatively easy to do. So we're just dividing this by 4. Which, you can do this in Dexter calculator. This is perfectly fine. We're going to get 18 plus 1i. So convert 18 into base 5. That's going to be 18 divided by 5. It's going to be 0.6, and then 3 is less than 5. Multiply this by 5 to get 3, which means this is 33 plus 1i, so that's just going to be 0, 1i. This is an example of where we have to add a 0 to a 1-digit number to make it fit the length of the other number. So we're inputting 3, 0, then 3, 1. And that is the correct answer. I'm not going to do the rest of the complexity module here because it's just going to be me doing the same thing I did for this module since we had every other sign. So thank you for watching this tutorial, and as always, have a nice day.